Today we are building a little game that feels like a real arcade ticket challenge, but in Python. You will pick a difficulty, the computer will think of a secret number, and you will guess it using smart hints. Along the way, we will practice loops, input handling, and random numbers. I will show you clean patterns you can reuse in bigger projects, like mapping difficulty to settings and avoiding messy nested logic. By the end, you will have a polished, replayable minigame. Let's wire up difficulty levels so they actually change the game. Easy will cap the secret number at 10 and give 5 tries. Medium will cap at 50 with 7 tries. Hard will cap at 100 with 8 tries. A small dictionary keeps these settings tidy and avoids scattered magic numbers. We will then ask for a level, look it up safely, and generate the secret with the random module. Clean inputs and predictable structure make this game easy to extend later. In this example, we will display the secret, but obviously hide that later on. Now the heart of the game. A loop that keeps asking for a guess until you win or run out of tries. We will guard against bad input, like letters or empty lines, using a try and accept block. Each wrong guess gets a helpful hint that says go higher or go lower. This keeps players moving without frustration. We also reduce the remaining tries and show how many are left, which adds just enough pressure to make it fun. Games feel better with a light menu flow. We will greet the player, ask for a level, then launch a round using the settings we chose. After each round, we will offer to play again. This keeps our code organized using small functions with one job each. The pattern is useful beyond games. For example, a data tool that runs a task, reports a result, then offers to run again with new options. Now let's add 3 small, very human touches. First, remember previous guesses so we can nudge the player if they repeat the same number. Second, warn if a guess is outside the valid range, because mistakes happen. Third, personalize the win message by showing how many attempts it took. Little moments like this make a simple script feel like a finished app, and they are the same habits you will use on professional projects. Here is the complete playable version that brings everything together. Save this as guessgame.py, run it, and try each difficulty. Notice the structure. A settings dictionary keeps numbers in one place. The playround function owns game logic, and main coordinates the flow. This separation is why the code reads easily and is simple to change later. Treat it like a template you can adapt for future mini projects. I tried to keep the code all on one page, but the font size would become too small. Hit me up if you want a copy of the full code. Time for a practical challenge. We will keep the same core game, but you will add 3 real features. First, a scoreboard that tracks wins and losses. Second, a custom level where the player picks the largest number and the number of tries. Third, a short summary at the end that shows the guesses made. I will give you starter code with clear tasks. Try it yourself, then I will show a complete example next. How'd you go? Here is one clean way to solve it. We added a function that safely collects custom settings. The round now returns whether you won, the list of guesses, and the secret, which allows main to update the scoreboard. At the end of each round, we print a small summary so the player sees their thinking pattern. Notice how returning data, instead of printing everything inside the loop, makes the code easier to test and reuse in other programs. Again, I tried to keep the code all on one page, but the font size would become too small. Hit me up if you want a copy of the full code for this challenge. Great work. You practiced loops, input validation, dictionaries for settings, and you turned a simple idea into a replayable game with a scoreboard. Next, we switch gears to real-world data. We will read and write comma-separated values files using the CSV module process rows and produce useful summaries. Think receipts, leaderboards, or small reports. Here is a short example that reads items, calculates line totals, and writes a clean output file you could email or store.